Okay, how do I start this?
Graph 6.
Go up to 6. Great. And then down 2, right 1. Down 2, right 1. Draw the graph. Now, if this is a skill you are still struggling with, today is going to be nearly impossible. You have to be able to graph lines, and you have to be able to do it pretty quickly and pretty consistently in order to do today's lesson. Any questions on the warm-up? All right, we're starting Chapter 3 today. Chapter 3 is all about systems of equations. Today we're going to solve them by graphing. All right, as you're getting yourselves organized, I'm going to just describe our lesson a little bit today. So a system of equations, it just means you have more than one equation that you're talking about. Remember, when you're graphing just one equation, every ordered pair on the graph is a solution. They make the equation true. So today we're going to look where two lines intersect, because that's on both of the lines, so it makes both of the equations true. So basically, that's what we're doing, graphing two lines and seeing where they cross. Here's our first example. Now, there's a couple different ways you could graph that first line, x minus 2y equals 4. Some people like to get it into y equals mx plus b. Some people like to use x and y intercepts. Do you guys have a preference? Okay, I'll do them all in y equals mx plus b then. So I need to subtract x from both sides. And then divide by -2. Great. So y equals, that's going to be 1/2 x minus 2. So we start at the -2 and then up 1 over 2, up 1 over 2. Now it's very important today that you use a super straight line. So you might want to use the corner of your ID or something. Nope, no erasing today. Alright, this one's already in y equals, so I can go ahead and graph it. So I'm going to start at 4, and then down 1, right 1, down 1, right 1, down 1, right 1. You can actually go until they touch. So the solution for this system is where they intersect. This is the ordered pair that's going to make them both true. What is the ordered pair right there? 4, 0. You go over 4, up and down 0. So we just did the first sentence in the directions. It says, then check the solution algebraically. So that means plug it in. I'm going to do that up top. So I would have 4 minus 2 times 0 equals 4. Is that true?
Yes.
Yeah. The second one, I would have 0 equals -4 plus 4. Is that true?
Yes.
Yeah, so if you plug it into both of them and it makes them both true, go ahead and box it in. It is for sure your answer. What are your questions on this?
Is the number not?
So that first one's going to be pretty easy to graph. It's already in y equals. So I'm going to go up to 6. Down 3, right 1, down 3, right 1, and draw your line. That second one, I need to get it in the right form to graph. You could also use intercepts. I wouldn't recommend intercepts here because one of them ends up being a fraction. So I definitely think this is the easier method. So I'm getting y equals -2/3 x minus 1. So I'm going to start at the -1. I'm going to go down 2, right 3. Alright, now I'm having a little problem because it doesn't look like they quite match up. So that could either be a operator error. I just didn't graph them correctly. Maybe my graph's not big enough. What do you guys think? Yeah, but think if I extended the slope from here down 1, 2, 3 over 1. So, yeah, if my line, I think I just didn't use a straight edge, so they look a little off. I think it's going to be right here. Okay, how do I check for sure, though? Yeah, what is that? 3, negative 3. So it should make them both true. So negative 3 equals negative 3 times 3 plus 6. It should make that true. It should also make this other one true. I'm out of space again. Does it make those both true? Does it check out in both equations? Yeah, it does. In this one I get negative 9 plus 6 is negative 3. That's true. In this one I get 6 plus negative 9 is negative 3. That one's true as well. So check, check. It works. Even though my graph looks a little off, this is definitely the solution. What are your questions? All right, how do I start this? Yep, minus 2x. I want to get y by itself. So this is negative y equals negative 2x minus 4. Then what? Yeah, I need to divide by negative 1, which is just going to change all my signs. So I can graph that one now. I start at 4. And I'm going to go up 2, right 1. You could also go down 2, left 1. So this is my line. Bless you. All right, this other one, what's that going to look like? Y equals 3.
Y equals 3.
Yeah, what does that look like?
Vertical, horizontal.
Yeah, it's a horizontal line through the y-axis at 3. Now, this is going to be one where it's extremely important to check because they're not meeting right at an ordered pair, and I don't think it's because I graphed it wrong. I think it's just because our answer is a fraction. So what do you think that fraction might be? To get to right here. Yeah, I'm going to check negative 1/2 and 3. So it definitely works in this one, right? Because you only have the y to plug in. 3 equals 3. So that one's not a big deal. But let's check the first one. That would give us negative 1 minus 3 equals negative 4. Does that check? Yeah, it does. So this is my solution.
Why do you have random numbers?
All right, example 4 is going to work out a little bit differently. All the ones we've looked at have one solution. So they cross at a point. That point makes them both true. However, sometimes they don't cross at just one point. It's actually the same line right on top of itself. So let's look at this one.
Oh, I see.
How would I start on that first equation?
Minus x.
Yeah, I want to subtract x. So we have negative 2y equals negative x minus 8. Then divide everything by negative 2. So I'm getting y equals 1/2 x plus 4. So I want to graph this line first. So I go up to the 4. I can't really go up 1, right 2, so I'm going to go down 1, left 2. Down 1, left 2. And so on. That's my first line. I'm going to graph my second line in red. So I start at the 4, down 1, left 2. Yeah, what's going on here? It's the same line. So what's my solution?
All real numbers.
Like this number over here? Would this be a solution?
The equation. Is there a solution?
You can't say all real numbers because it's not all real numbers. Okay, all real numbers would be like if the whole graph was covered. But there are many possible solutions. So you could say infinitely many solutions. You could say many solutions. You could say all ordered pairs on the line. Whatever. Just somehow tell me that there are lots and lots and lots of answers. Many solutions is the easiest way to do it. Any question on this? All right, let's jump to the other special case so you guys have some time to work on homework. How would I start this one? Shh, we are not done. Yeah, subtract 2x from both sides. So I'm getting y equals negative 2x plus 5. So I'm going to start at 5. Bless you. I'm going to go down 2, right 1, down 2, right 1. Graph that line. Okay, now I'll do the other one in black. I'm going to add 2x to both sides. That's negative y equals 2x plus 1. You got to change all your signs here. So now I'm going to start at the negative 1, down to right 1. Could also go up to left 1. What kind of lines are these? So where do they intersect? Nowhere, okay? A good tip off here that it's going to be no solution is, look, their slopes are exactly the same. We know when the slopes are exactly the same, they're parallel lines that never intersect. So the answer is no solution. Now, if you see it's no solution or many solutions before you graph, that's great. But if you're solving by graphing, I still need to see a graph. So don't think you get out of the graph just because it's a special case. 11 through 51, only odds though. You can check the answers in the back of the book. It's also on your green sheet. I'll take questions on these tomorrow at the beginning of class. You have the rest of the hour to do homework.